Hi everyone. So today we are going to look at transforms, and this is going to be an introduction to when we get into the Laplace transform, which we can use as an alternate method to solve transient circuits, as we have done before with first and second order circuits. So at the end of this session, I hope you should just be able to describe what we mean by the term transform, because it is something you'll use a lot during your course of study: Laplace transform, Fourier transform, Z transform. So you should have an idea of what you're actually doing in a common sense way um, when you're doing these mathematical transformations. So let's take the example of determining the number of marbles in a jar. So um, what we're going to do is we're going to look at different ways we could solve this. We're going to transform the problem into different domains. And this is essentially what transformations are. They're function mappings. And as you'll see, they'll be useful because solving the problem in one domain or the next could make it easier. So, what are the strategies for doing this? Well, the first thing we could do is we could empty the jar and count out the marbles individually. So we could take out, and every time we remove a marble, we could count that as one operation. And if we have 1,000 marbles, then we have 1,000 counting operations in order to find the number of marbles. So that is one approach. The next approach is that we could weigh the jar and divide it by the weight of a single marble. Right? We'll ignore the fact that the jar has a weight for this purpose, just to simplify the explanation. So if we do that, we're basically looking at less operations, because we're going to weigh the jar, which is 1, and then we're going to divide it by the weight of a marble, which is 2 operations. So that's 2 operations as opposed to thousands of operations. So you'll see that the counting strategy is long and tedious. Although it might be simpler to do each one, it is much longer and much more tedious if the problem becomes bigger. The weight strategy involves the use of transformation tools. In this case, we need a scale. So we weigh the jar or a scale, we get the total weight, and then to bring it back to the number domain, we have to use an inverse transformation, which in this case is dividing it by the individual weight of one marble. So this is indirect, but it is shorter, and it also requires a method to move between the domains. When we were simply counting the marbles, we were working directly in the number domain. So we are just taking out the marbles 1, 2, 3, 4, and we're directly counting them. Now we are not doing that. We have to take all the marbles, the total number of marbles, and we transform that into a weight. So in the weight domain, there are no 10 marbles or 1,000 marbles. The weight would be in grams or kilograms. And then we transform that by the weight of a single marble, and we bring it back into the number domain. So this is exactly what we're going to do with our mathematical problem, except instead of using a scale to convert, we're going to use what we call a transformation, and a mathematical transformation. In this case, it's the Laplace transform. And just like we need one method to go to the domain, we also need a method to come back from the domain. So we have a Laplace transform that will take a function in time, as we see here, f of t in time, and when we apply the Laplace transform, we get f of s. And notice we have common f of t here and capital F of s here. The s is common, and this is now in the s domain where there's no concept of time, and that the way we do that is through this integral here. So that takes us to the Laplace domain. So once we have performed this integral, we move from something in t, and you can see we are integrating with respect to t here, so the t's will all come out when we substitute our limits, and we will remain with something in S. And once you're in that domain, whatever operations we perform, when we want to bring it back to the t domain, we have to perform the inverse function. So we have this L inverse, and in this case we are operating on the S domain function, and that will give us back the t domain function, and we also have an integral associated with that. So this is what we're going to do in our circuit problems. We're going to have a time domain problem. We're going to transform it into the Laplace domain and solve it, and then we're going to bring back the solution into the time domain. And that is what we will be looking at in the remainder of this section. So by now you should be able to describe what is meant by the term transformation, and you should have some basic understanding of what that means for the Laplace transform. And next time we're going to look at some more specifics and some more functions and how they move from the time domain into the Laplace domain.